Hi, I'm going to talk about future value calculations, the future value of a single amount and the future value of a series of amounts, in other words, future value of an annuity. Up until now, we've calculated the future value based on an annual time period, and now oftentimes that frequency of compounding is going to be more frequent than a month, and of course the more frequently it compounds, the more you earn. So we're going to take a look at monthly compounding. If you put your money in a bank, they probably compound daily. So let's begin by populating this first table with our data. How much will I accumulate in 3 years if I put away a one-time deposit, a lump sum of $1,200 this year, earning 5%, and I'm going to keep it in the bank 3 years, and I'm not going to do a recurring payment or deposit, and I'm going to do a one-time of $1,200. All right, so monthly. If we have a 5% annual interest rate, our monthly interest rate is going to be 5% divided by 12. If we have a 3-year time period in months, that's going to be 3 times 12 months. 3 years times 12 months in every year. This is 0. And since it's just a one lump sum, it's not recurring at all, our present value is going to be the same. All right, so since we've been using the insert function dialog box, this time I'm just going to type it in. So equals FV. You see the first thing to highlight here is the rate. So I'm going to click on the rate. I'm going to press the comma, and then N per highlights. So I'm going to click on the 3 years, comma. Now payment is highlighted, but I don't want that, so I'm just going to hit a comma again. And now PV is highlighted, and I'm going to negate that and click on the $1,200. And Excel is so forgiving that I can press enter here without closing the parenthesis. So after 3 years at 5% interest per year with annual compounding, it's $1,389.15. Now, you notice this little fill handle in the bottom right corner of the active cell? Well, I'm going to click on this cell, and I'm going to drag my formula by that fill handle, and it's going to copy and paste that formula over to the next column. So you see, the references were relative, so they changed relative to where I dragged them. And if you want, you can still even open up the insert function dialog box. All right, so does this pass the sniff test? Yes, it does. We earn a little bit more interest by having it compound monthly, $1,393.77. So let's do the same thing down here, future value of an annuity. This is a series of equal payments. That's a definition of annuity. So if I put $1,200 in every year for the next 3 years, I can earn 5% compounded annually. So let's populate that. 5%, 3 years, payment, $1,200, present value is 0. All right, now let's do this monthly. So it's going to equal the 5% divided by 12. It's going to equal the 3 years times 12 months in every year. And now instead of, we weren't worried about it when we were making a single payment, but now we're making a series of payments. So we're going to express those in terms of months. So that equals 1,200 divided by 12 months in a year. All right. So present value 0. Let's enter our future value. FV. Oops, I missed my equal sign. Equals FV. My rate, comma, my N per, comma, my payment. I'm going to negate that. And I can close off my parentheses. So I would have $3,783. I'm going to drag this by the fill handle. And I'm going to see that this does pass the sniff test. Look at that. I'm going to have $3,875. So we're going to have a little bit more with that monthly compounding.